Okay. In this video, we'll be solving some problems based on Laplace equation. In the previous video, I have derived the equation for Poissons and Laplaces. So here we'll be solving problems based on the Laplace formula. So we know the Laplace equation is nothing but del square V is equal to 0, right? So the del square V operation, what we have, it can be written, it has different forms in different coordinate systems. If you take the first coordinate system, that is Cartesian system, the equation for del square V will be given like this. It is dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square equal to 0. If I make it equal to 0, it is Laplace equation. Okay. So as you can see here, you are going to do double differentiation here. This is partial differentiation with respect to x, with respect to y, and with respect to z. And since you are having square, we are going to differentiate twice. Okay. Similarly, for cylindrical system, the equation is this. You have 1 by r, dou by dou r of r into dou v by dou r plus 1 by r square, dou square v by dou phi square plus dou square v by dou z square. And for spherical system, it is 1 by r square, dou by dou r square, dou v by dou r, plus 1 by r square sine theta, dou by dou theta of sine theta, dou v by dou theta, plus 1 by r square sine square theta, dou square v by dou phi square equal to 0. Okay. So these are the equations you have for different coordinate system. So when the problem is given, you have to check which coordinate system it belongs to, and you have to use that equation to solve the problem. Okay. So we are going first now start off with the first question here. They're given determine whether or not the following potential fields V satisfy the Laplace equation. So they're asking you to check whether the given equations are satisfy Laplace equation or not. So we know the Laplace equation is del square V equal to 0. So you have to perform this del square V for different equations, and in the end you should get 0 as the answer. If you get 0, it means it satisfies the Laplace equation. If you don't get 0, it means it does not satisfy the Laplace equation. So we'll start off with the first one, first equation, that is V equal to x square minus y square plus z square. Now if you see the axes or the coordinates are x, y and z, which means this is Cartesian system. Okay, so they have given you the equation in Cartesian coordinate system. And if you have Cartesian coordinate system, you see here the Laplace equation will be this. Okay, so we'll use this equation now. So I need to find del square V, which is dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square equal to 0. I have to perform these differentiations first, then add the result to, and I have to check whether the result is 0 or not. Okay. So the given equation is this, x square minus y square plus z square. So first I will perform this differentiation, dou square v by dou x square. It can be written as dou by dou x of dou v by dou x. You can split this double differentiation into two terms. So first we will do the inner differentiation, that is dou by dou x of v is nothing but x square minus y square plus z square. Okay, so dou by dou x of, you are doing partial differentiation with respect to x, which means other than x, all other terms are assumed to be constant. So now the differentiation of x square with respect to x will give you the answer as 2x, whereas differentiation of y and z is going to be 0. You're doing partial differentiation, no? So the other two terms will be taken as constant here. So you're getting 0 as the remaining term. Now again I have to perform the differentiation of 2x, which will give me the answer as, okay. So the first differentiation term, dou square v by dou x square, can be split into two terms, dou by dou x of dou v by dou x, and individually I am doing differentiation one after the other. And since you're doing partial differentiation, other than the term with respect to which you are differentiating, remaining term should be assumed as constant. Okay, so the first one is done. Now the second differentiation term, that is dou square v by dou y square, that also is split into two parts. So you will be getting now dou by dou y of the same equation. The equation remains the same. You are just differentiating it with respect to different denominators x, y and z. So this differentiation is now going to be, differentiation of x square will be 0, differentiation of minus y square will be minus 2y, and differentiation of z square is 0. And again this is differentiated and you will be getting the result as minus 2. Okay. Similarly, for the last one, I'm just splitting the double differentiation into individual. Separate it. I'm separating it. That's all. So in this case, x and y are constants, so differentiation becomes 0. And for the last one, it will be 2z. And after again differentiating, you're going to get the answer as 2. So now I have the individual values. Now I just have to add them. Okay. So del square v will be, I got first answer as 2, second answer as minus 2, third answer as plus 2. So the answer is, final answer I'm getting 2. As you can see, it is not equal to 0. After simplification, after adding them, your answer is 2, which is not 0, which means the Laplace equation is not satisfied. Okay. The given question, that is v equal to x square minus y square plus z square, this equation is not satisfying Laplace's equation. If at all, if you had got the answer as 0 here, then you can say that it is satisfied. Okay, I hope you have understood this problem. Any equation is given, any potential value is given, you have to check which coordinate system it is. And based on the type of coordinate system, you have to use that equation, that is out of the three. Any one of them will be there. If it is Cartesian, this. If it is cylindrical, this equation. If it is spherical, you have to use this equation. And then you have to individually find the terms, substitute it, and check whether the answer is 0 or not. If it is 0, it is satisfied. If it is not 0, it is not satisfied. Okay, this is how you solve the Laplace equation problems here. So we have done the first part here. First question is solved. You have two more equations given. So let us take the second equation, that is v is equal to r cos phi plus z. Okay, so the second question is v is equal to r cos phi plus z. So here the coordinates are r, phi and z, which means this is in cylindrical system. Okay, and for cylindrical system, the del square v equation will be 1 by r dou by dou r of r into dou v by dou r plus 1 by r square dou square v by dou phi square plus dou square v by dou z square equal to 0. Okay, so this is the equation for Laplace for cylindrical system. So individually we have to find these terms and then add it. So first we'll consider the first one, 1 by r dou by dou r into dou v by dou r. So 1 by r dou by dou r into r dou by dou r of, in place of v, put this equation here, r cos phi plus z. So now what you're doing is differentiating with respect to r, right? So other terms will be kept constant. So differentiation of z with respect to r becomes 0. Whereas for the first term, differentiation of r cos phi with respect to r will give you the answer as cos phi. Okay. Now further, if I differentiate this with respect to r, again I am going to get cos phi as the result. So I got cos phi by r as my first answer. Okay. That is, this part is done. Now coming to the second one. That is 1 by r square dou square v by dou phi square. So I'll keep the 1 by r square as it is. I'll split this into two differentiations like this. Okay, square term is just split into two. So for the first differentiation, again replace v by the given equation. So again you're doing partial differentiation with respect to phi, so z value will become 0 here. So you have 1 by r square dou by dou phi of the differentiation of r cos phi becomes minus r sin phi. Okay. Again, if you differentiate, you will be getting minus r. Differentiation of sin phi is cos phi divided by r square. So the final answer will be minus cos phi by r. Okay, so first two terms are done. Now the last one is dou square v by dou z square. So dou square v by dou z square. So I'll again split this into two. Okay, dou by dou z of r cos phi plus z. Okay, so here if you differentiate now, if you see the first term does not have any z component, so it becomes 0. And the second component has z, whose value is going to be now, differentiation of z with respect to z will become 1. And differentiation of a constant is 0. So finally you got the answer as 0 for the third term. So you have the three answers now, cos phi by r, minus cos phi by r, and 0. Add all the three result. So you'll be getting cos phi by r minus cos phi by r plus 0. So you see these two get cancelled and you're getting the answer as 0, right? You got the del square V answer as 0. So hence you can say it satisfies. Hence you can say that this particular equation satisfies the Laplace equation. Okay. So similarly you can try the third question, that is, just a minute. Okay. So the third one was V is equal to R cos theta plus phi. This is now in spherical coordinate system. So use this equation to solve it and check whether it is satisfying or not. Okay, so you can try the third one and you can get the result for this. So this is your first problem. This is how you solve the Laplace equation problem. Okay. So once you are done with this, complete this problem. Okay, complete this question, and then you can try the this problem, second problem. Verify that the potential field given below satisfies the Laplace equation. The same as your previous question. As you can see, it is given x, y, z. X, y, z means it is Cartesian coordinate system. So use the equation for Cartesian coordinate system and solve this problem. Okay. With remaining problems, I'll do in the next video.